Hello, this is my LB-274 final project, and the topic at hand is capacitance. Just a little bit on what capacitance is, some background. It is the ability of a system to store electric charge. Electric charge is stored as a form of energy in the capacitor. It is also expressed as the ratio of the electric charge on each conductor to the potential difference. Capacitance is a measurable value within its conductor known as a capacitor, and its SI units are farads, which is demonstrated as capital F. The capacitor consists of two sheets of metal, which is conducting material with an insulator sandwiched in between. This insulator can be anything in terms of cardboard, paper, plastic, anything of that nature. And it also maintains energy taken in from source even after disconnection, although there's some minimal leakage when unplugging the battery from the capacitor plates. As current through the electric circuit known as energy or voltage is collected, each plate holds its each equal magnitude of the charge, one being negative and the other being positive, depending on which direction the current is flowing from the battery. Just a little introduction into my research. The research question at hand is how does varying solutions and their dielectric constants impact the voltage, charge, capacitance, and energy within a capacitor? The goal for this experiment was to recreate a homemade capacitor and observe its relationship with liquids in an electric and energetic manner. The motivation behind this was during the FET capacitor lab during class. I was eager to see how the capacitor would be impacted in different liquids, but there were no options to create those conditions within the simulation. So I decided to recreate the simulation within the experiment at home. Below are the hypotheses for the variables that I'll be testing in this experiment. A little bit about the experimental design. First, the capacitor was made by placing aluminum foil on both sides of a sheet of cardboard. The capacitor was then completely sealed off by sealing off with electrical tape. 4 capacitors were made with identical dimensions to account for solutions permeating the cardboard. Each trial consisted of placing the capacitor and liquid in a Tupperware dish connected to a 1.5 volt battery via wires in a circuit. The 4 different treatments were air as the control, water, vinegar, and isopropyl alcohol. While connected to the battery source, voltage and capacitance was measured using a multimeter, and in turn, those values were recorded and calculations were done to determine the charge to compare the known dielectric constant to experimental to test the accuracy of the measurements from the multimeter. Here's a little bit of a setup, the pictures of the capacitor and the multimeter and circuit of the battery. The dimensions of each of the 4 capacitors was 7.5 inches length, width of 4 inches, and then the height or distance between the 2 capacitor plate sides was 1/8 of an inch, giving it an area of 30 inches squared, and the volume or the voltage of the battery is actually 1.6 volts as it was fresh out of the battery pack. In order to minimize error, as stated earlier, 4 capacitors were made using a different one for each trial with each treatment. Air was used as a control for the experiment and its values to determine the charge of the plate since it was known to be a constant value prior to starting the experiment. The battery voltage was recorded prior to starting the experiment in order to determine the initial voltage, and all readings were sampled 3 times, and the average of the 3 trials were the data set that was recorded. Here we can see the relevant formulas I used in order to calculate charge, capacitance, as well as the energy stored within each capacitor. And here's the computational work. We can see at the top, calculating for error, using our control as air to determine the charge for each of the system as it was constant throughout, which was known prior to study. And we see that within each of the 4 treatments, I calculated the capacitance theoretically based off the known dielectric constants, as well as the experimental dielectric constant from the capacitance reading from my multimeter and the energy stored within the capacitor. Here we see the data. On top, there's a key. CT stands for theoretical capacitance, which was calculated using the known dielectric constant. Then we have our multimeter reading, which is experimental capacitance, our known dielectric constant, and then our experimental dielectric constant, which was calculated using the experimental capacitance. That was compared to the known dielectric in order to determine accuracy. And as we can see throughout 4 trials, that the experimental dielectric constant was fairly close to the known, shown within water was within 5% of the actual dielectric constant of water. We see here that air had the highest energy stored, whereas isopropyl alcohol had the lowest. After analyzing the data, a few conclusions were drawn. It was shown throughout the measurements that voltage remained constant through all trials, regardless of liquid or lack thereof with the air. This was always equal to the voltage of the amount found in the battery, which was 1.60 volts. The magnitude of charge for each plate was constant for the varying trials, which was 0.090 nanocoulombs. And the capacitance is inversely proportional to dielectric constant, where it was found that the magnitude or the energy within the circuit was inversely proportional to capacitance itself. The common theme was that an increase in dielectric constant resulted in a decrease in capacitance and an increase in energy in the system. As shown with air, air had the highest per se dielectric constant, was the Kc value of 8.99 times 10 to the ninth, but it also had the most energy stored and the lowest capacitance of all four of the treatments, whereas isopropyl had the lowest capacitance and the least energy stored, or the lowest dielectric constant and the least energy stored. It was shown that throughout all four of these treatments and trials, that voltage and charge were unaffected by dielectric constant change, as those remain constant within the trial. Here are my references from my experiment, and thank you for listening.